Hello everyone, welcome to Eduxcite classes. In today's session we will solve topic 11, electromagnetic induction paper 1 MCQ. Okay, so before solving this video, it's a small request to please download the worksheet first, solve it and then see the solution for the answers. Okay, so let us start with the very first question. A conductor in the shape of a solid square is moving with a constant velocity. So this is a constant velocity and this is the conductor. Magnetic field is given you into the page of the paper. They are asking you which diagram correctly represents the separation of the induced charges. So we know that to find out the induced charges we use the Fleming's right hand rule. Okay, so according to the Fleming's right hand rule, FBI, the thumb represents the force on the direction of the motion of the conductor, B stands for magnetic field and I stands for the direction of positive charge or the direction of current. So let us apply here. Magnetic field is into the page, velocity, that is the direction of the motion, is in the upward direction. So the thumb is pointing in this direction, sorry, the second finger is pointing in this direction, which means that the positive charge is moving this side. So this will be positive and automatically this will be negative. So just check, option A is the right answer. Okay. Question number 2, very simple. A uniform magnetic field strength B completely links a coil of area S. S is the area of this coil. The field makes an angle phi to the plane of the coil, the magnetic flux. So we know that magnetic flux is what? Phi is equals to BA cos of theta. But this angle is, theta is the angle between your area vector and magnetic field vector. So magnetic field is already given. Now area vector is very important, and here only the student misunderstood this concept. If this is the coil, area will be perpendicular to it. Area vector I am talking about. The direction of the area. Area is a scalar, I know, but area vector is the concept to determine the direction of the aerial things that we are considering in this flux. So if this is the coil, area will be perpendicular to it. Now here you can see the B, this is the magnetic field, this angle is phi, and if area vector is this much, so this will be 90 minus phi. Okay, so this will be your S vector. So here A represent S, so this will be 90 minus phi because this is 90 degree. Okay, so according to this, this is B, A stands for S, so BS cos of 90 minus theta, and we know that cos of 90 minus theta is what? Sin theta. So the option will be, or here the theta is phi, so phi, this will be phi. So BS sin phi, option C is the right answer. Okay. Question number 3, the Faraday's laws of electromagnetic induction states that the induced EMF is, so we know that according to the law of Faraday's law of electromagnetic induction, EMF induces minus of d phi by dt, n times, n is the number of turns. So d phi by dt, that is nothing but rate of change of magnetic flux. So rate of change of magnetic flux linkage, B is the right answer. Now the fourth, magnetic flux through a coil of 500 turns, very specific, there are 500 turns and the diagram is given. Again the magnitude of induced EMF, this is flux versus time. So we know that d phi by dt is what? The induced EMF, magnitude of induced EMF. So you can find out the slope. So the slope of magnetic flux versus time gives you the induced EMF. So EMF will be equals to change in y, 2 minus 0 upon 4 minus 0, which is 2 by 4, which is 1 by 2, and this is for one coil. So how many coils we have? 500. So the EMF of the coil will be 500 into 1 by 2, which is 250 volt. Okay, so the answer is C. Now question number 5, change in flux over time. There are many questions guys, so your basics should be very clear. So the flux versus time graph again is given. Which of the following gives us the best estimate for the induced EMF in the coil? Again we know that EMF is what? d phi by dt. Okay, minus of d phi by dt. Now here you can see the slope, you can see this theta is less as compared to this. The gradient or the magnitude of the slope is lesser than the magnitude of the slope of this. So you can say once the flux is 0, there will be no induced EMF. There is a gradual change, it means it is a straight linear line, therefore there is a rate of change of magnetic flux linkage is constant. It is increasing with a constant rate, therefore the EMF induced will be constant. So that will be constant, and you can see the area will be the gradient will be this, which is less than this. So the magnitude of this will be less than this, which is applicable here. Both are equal, and if this is incorrect, here it there is a change in the EMF also, which is not happening because it is a linear curve. So whenever there is a linear curve, it will not happen. Okay, so for example, this and this will not be possible, only option A. And you can see here it's a linear, so it will be constant value. It's steeper, so it will have a greater magnitude because the rate is increased. The change of rate of magnetic flux increases, therefore the value of the induced EMF will increase from the previous value. So option A is the right answer. Similarly, question number 6 again, magnetic field strength varies with time is given in a closed loop of a metal wire. The current induced in the loop during that period. So we know that the current will induce only when there is a change in magnetic flux linkage, and due to change in the magnetic field, there is a magnetic field flux is changing, which is only possible in the time period T1 and T3. You can see there is a change. This is almost constant. So if the magnetic field is constant, there is no change in magnetic flux because rest all things are same. So if there is no change, there will be no induced EMF, and no induced EMF means there will be no induced current. So therefore in this region only there will be no induced current. T1 and T3 will have induced current. So T1 and T3, option D is the right answer. Question number 7. The north pole of a permanent magnet is pushed along the axis of a coil as shown in below. The pointer of the sensitive voltmeter connected to the coil moves to the right. So this moves to the right and gives a maximum reading of 8 units. Okay. So if this is north pole is coming towards this is moving towards the right with a maximum value of 8 units. Now the experiment is repeated, but on this occasion the south pole of the magnet enters the coil. Now this has reverse, this is south, this is north, and the coil is moving twice with the previous speed. If this was moved with V, now the south pole is moving with 2V. So if the rate is increasing, the rate of change increases just by double. So the unit instead of 8, now it will be 16 unit, and as the poles are interchanged, so it was initially at the right direction, now it will be in the left direction. So 16 unit in left direction. So which is option D is the right answer. Okay, simple. Now question number 8. The diagram below shows two concentric loops lying in the same plane. The current in the inner loop is clockwise and increases linearly with respect to time. So you can say the current is increasing. Now if a current carrying conductor behaves as a magnet, and it will have its own magnetic field. Now if the current increases, means the magnetic field also increases, the strength of the magnetic field also increases. Now according to the Lenz's law, the outer loop will induce the current in such a manner that will minimize the effect, or you can say which opposes the effect due to which it has been produced. Now you can see inner loop is producing a magnetic field using the right hand thumb rule. So it is moving clockwise, the thumb is going into the page. So the magnetic field is into the page due to the inner coil. Now the outer coil will produce a magnetic field in such a direction that it will come out of the page, because initially it is into the page for the inner loop. For the outer loop, it will be out of the page according to the Lenz's law, because it will oppose the change. Okay. So for out of the page, it will have to move counterclockwise. Okay, counterclockwise, and that too the induced current will be constant, because the rate of change of current is a linear. This is linear, it means magnetic field is changing constantly. If the d phi by dt, again that rate of change is constant, therefore the induced current will be constant but in anti-clockwise direction. I hope I have tried my level best to explain this. Even though if you have doubt, you can comment below. I will try my level best to clear all your doubts. Also, you can find out the PDF of this video. The link is given in the description below. Even my previous video, if you have not watched, you can download the worksheet as well as the PDF of what I am doing in my videos. Okay, the link is all is given in the description. Okay, question number 9. The diagram shows a coil of wire wound over an iron core. This is a battery and this is connected. This is an iron core and the wires is wounded over an iron core. When the switch is closed, the ammeter gradually increases from 0 to a maximum value. Okay, this value increases gradually. Explanation for the gradual growth of current. We know that due to the soft iron core, when the current is flowing through it, there will be an induced EMF in the coil itself. So you can say the growth of the current is an EMF is induced in the coil. That's it, simple. Rest all are the EMF of the battery. No, there is no change here. Iron core has a very low resistance, that doesn't impact the value because it is connected with the wire. The battery has a larger internal resistance. No. Okay, so option A is the right answer. Question number 10. A resistor is connected in series with an AC supply of negligible internal resistance. The peak value is V0 for the voltage and for the current it is I0. So average power, so P average is what? IRMS into VRMS. Okay, and IRMS is I0 by root 2. It is the relation is given in your data booklet. VRMS is V0 by root 2. So this will be V0 I0 and root 2 into root 2 is 2. So option A is the right answer. Okay. Now question number 11. A lamp of resistor R is connected in series to again a AC supply. The RMS value is, so this is the VRMS is given to us as 20 volt. The variation with time t of the power is given of a light bulb. So you can see the peak power is P0 is 100. So the best estimate for the value of resistance. So we have to find out the resistance of the lamp. Okay. So power is P0. So P0 is equals to this is power, right? So P0 is equals to V0 into I0, right? Or V0 square by R, you can say V0 square by R, and P0 is 100, V0. So VRMS is given, so V0 by root 2 is VRMS, right? So you can say V0 will be VRMS times root 2. VRMS is 20 into root 2. So V0 square. So I can write down this as V0 square is 20 root 2 ka square divided by R. So R will be 20 square. So it will be 400 into 2 divided by 100. So which is equals to 8 ohm. So answer is 8 ohm. Very simple. Question number 12. The diagram below shows the variation of time t and the EMF E generated in a coil rotating a uniform magnetic field. So this you can say this is the EMF generated in a rotating coil with respect to time. The RMS value is ERMS of the EMF, also the frequency f of the rotation of the coil. So we know that ERMS will be equals to small e by root 2. This is the relation for ERMS. So this A and B gets cancelled, so we have to think in. Now there is no change in the frequency, so frequency is equals to 1 upon time period. So this is the 1 upon time period for one rotation. So frequency will be 1 upon time period and ERMS will be E by peak value of the EMF divided by root 2. This is given in your data booklet. Okay, so very simple, and there is no change in the frequencies, right? The frequency will remain the same, and relation between frequency and time period is also given in your data booklet. Just refer it. Now this is very interesting question. Question number 13. The graph below shows the variation with time t of the current I in a resistor. So you can see this is not changing. Only the signs are changing after fixed interval of time. It is not gradually changing like a wave. Okay. So we should know the basic of the RMS concept. So what will be the root mean square value of the current in this case? So how we get the concept of root mean square? Because in an AC supply, over a period of time, some values are in positive, some values are in negative. If we take out the average, we come out to be 0. So there we get a concept of RMS. What we do the square of the first thing. So by squaring, the negative value becomes the positive. So like for example, this and this. So we do the square. So square means if this is I naught, so this will be I naught square. This minus I naught, then making it square, it will again become I naught square. So for one cycle, if I take this much, so I will square the values. So by squaring, I will get, let us say, this. So this is I naught square. So this step is done, squaring. Then we take mean. So I naught square by 2. I may take the mean and then I take the root. So I will take the root now. So this is what? First I have to take I naught square plus I naught square, because for one complete cycle it is I naught positive and minus I naught square. So this is, and then I take mean. So this will be 2 I naught square by 2. So this is the first step, squaring. Then mean I have taken. So this is the mean I naught square, and then root again. So the I naught square root will be I naught only. So the option will be B, not I naught by root 2, because I naught by root 2 will only be possible when there is a wave type of change of the values for the voltage and the current. But for these type of, you have to go for the basics. Okay. Question number 14 now. The RMS value across the primary and the secondary coil in an ideal transformer is given. Which one of the following is always true? So for ideal, it is mentioned ideal transformer means 100% efficient. So power input is equals to power output, which means that the secondary power is what? V into I. So Vs Is is equals to Vp Ip. Ip and S stands for primary and secondary. So option C, it's a direct question. Question number 15. This is an ideal transformer again. Okay, this is the graph is given. The transformer has n turns in the primary and 2n turns in the secondary. Rest all is remaining the same. This is the CRO we are getting. So what we will get for the secondary coil? So you can see, if just the number of turns are doubled, so the amplitude will get double, but there will be no change in the frequency. So there will be 3 blocks for the half cycle, and it will be like this, 2 blocks for the amplitude. So this is only possible, you can see, for option B. Rest all are incorrect. Now question number 16. This is a fluctuation of current with respect to time in an ideal transformer. Which time will the magnitude of the induced EMF in the secondary coil will be maximum? Now for induced current to be maximum, the rate of change of current should be the maximum, because then only the induced EMF will be maximum. Because the rate of change of current is maximum, means the magnetic field is also maximum change, and that will result into the maximum change in the induced EMF magnitude. So you can see, the steeper the curve, more is the change, so which is only possible for C. So you just say d5 by dt is the induced EMF. Okay. So the current is changing, magnetic field will change, magnetic field strength changes, due to that magnetic flux changes resulted in induced EMF. Okay. So everything is interlinked, you have to connect the dots. Question number 17. Again it is based on transformer. Primary coil NP turns, secondary coil NS turns, alternating voltage supply is the frequency F, and RMS value for primary coil is Vp. We have to correctly give the frequency and the RMS voltage for secondary coil. So this is given in your data booklet also. Vp upon Vs is equals to Np upon Ns is equals to Is upon Ip. This relation is given in your data booklet. So if we want to find out the RMS values, so for secondary, so Vp times Ns upon Np is equals to Vs. So you can say this is incorrect. So either this or this. Now as I mentioned, there will be no change in the frequency, because the way the frequency for the primary is there, the same frequency will be there for the secondary. So option D is the right answer. There will be no relation for the number of turns and the frequency. They are independent of each other. So only option D is the right answer. Okay, question number 18. High voltage are used for the transmission of electric power. Now many times the student has asked, sir, power is equals to V square by R, I square R and Vi. So why we are considering this only? Now the answer lies in the concept of Joule's law of heating, which mentioned that there is a side effect of the current. Whenever a current flows through a resistor, there is an heating effect. Now in this case, the transmission lines are from the power plant to the consumer. So there is a long transmission line and the current is flowing through it, and there is a resistance of the transmitting wires as well. So we are using I square R because that is the heat loss during the transmission, and this is only asking for the over a long distance high voltage are due to the power loss. Okay, so this is power loss, transmissions are minimized, high voltages are used. So high voltage means current will get lower down, then the heating will be minimized, and this was the question I was answering here, this one. So here you can see which power loss is because of the formula I square into R, which is option C. 0 is not the possible. V square by R we only used for localized resistor or for a given resistor. Okay, and here it is a transmission lines over a long distance. So we are using I square, and VI is used for at a particular point on at a particular resistor in a electric circuit, at a specific location or at a specific resistor, then we are using this formula. But here it is a long transmission line, so we have to use I square R to find out the heat loss or the energy or the power loss during the transmission. Okay, now 11.3. A capacitor is charged to 6 volt and then isolated from the battery. So, and the plates are then pulled apart, so their separation is twice as big. So 1 is the formula of capacitance is equals to area into epsilon divided by D. D is the separation between the plate, and we know that V is equals to Q is equals to CV, so V is equals to Q by C. Okay. Now by doubling the separation, so it becomes 2, so new C dash will be C by 2, right? So new V dash will be Q upon C by 2. So C by 2 means it will be 2Q by C, and this Q by C is equals to 6. So V dash will be 2 times of 6, which is 12 volt. Okay. So read the question carefully, make the relation between the information which is provided, and accordingly you have to solve. If you even didn't get, just comment below. I will try my level best. Even the PDF is available, you can download. The link is given in the description. And the last question for the video, a parallel plate capacitance 10 picofarad is charged by connecting a 6 volt battery. Now the plates are now pushed close together. Which of the following statement is true? Now we know that if capacitance is equals to A epsilon by D for a parallel plate capacitor, this is the formula. This is given in your data booklet, no need to worry. Now if you can see, it is pushed closer, so if D is minimized, capacitance increases, it is inversely proportional. So if it is capacitance increases, it means that more charge can be, capacitance means the holding capacity of the charge on the plates, right? If the capacitance increases means more charge flows onto the capacitor, rest all are incorrect. Okay, charge will not flow off across the capacitor plate, not possible. No charge flow, no. So if you make closer, the capacitance increases means more charge can be put onto the parallel plates. As a result, the capacitance increases. Okay, so I hope I have tried my level best to explain each and every question. Even though if you have doubt, please comment below. I will be very happy to clear all your doubts. Okay, thank you. Wish you all the very best. See you in the next video. Keep learning.